Good morning, everyone. I'm Leila Aguilera, Territory Manager of Jefo Nutrition in Quebec, Canada. And I want to thank you, all of you, for joining us this morning in this webinar. The two topics chosen are of general interest on the poultry industry and are in line with our Jefo solutions. We have been pleased to receive many registrations and we have a large participation at this time. For today, we have two 40-minute presentations with 3 speakers. All the microphones and camera of non-speaker will be closed through the webinar to facilitate communication. After each presentation, we will have 15 minutes for a Q&A period where we'll be able to answer all the questions written in the box during the presentation. At the end of the webinar, you will receive a survey that we invite you to complete. In the next few days, you will be able to receive the presentation in PDF format and the video of the webinar. I would like to begin by welcoming my colleague, Jared Osford. Jared's passion and expertise is in poultry nutrition, parasitology, and research. Jared joins the Gaydos Technical team in July 2020 after completing his PhD studies in immunology and nutrition from the University of Georgia, where he also pursued his master's studies in nutrition. Jared is a key member of Jeffo's Technical Service team for North America, and we look forward to meeting you in person as soon as we will be able to. In the meantime, we welcome Jared, who will be our moderator this morning. Thank you.
Thank you very much, Leila. Today, we are going to be talking about raising healthy chickens in a challenging world. As many of you know, there's been a lot of changes to our production systems lately that have really changed how we think about how we rear our chickens. Our first presenter today is Dr. TJ Gaydos, Gaydos Consulting. He is a graduate of the Ohio State University College of Veterinary Medicine. He earned his master's in avian medicine from the University of Georgia and is a diplomat of the American College of Poultry Veterinarians. As the owner of Gaydos Technical Services, LLC, TJ works as a private consultant to the poultry industry. Dr. Gaydos has spent his veterinary career working to improve intestinal health, animal welfare, production efficiency, and reduce zoonotic diseases. He works extensively with the coccidiosis, intestinal health, probiotics and prebiotics, and other antimicrobial feed additives. Today, TJ will be discussing Alphabet Soup, the U.S. experience for reduction of antibiotic use in poultry. Take it away, TJ.
So we're talking about the U.S. experience for a reduction of antimicrobial use, antibiotic use, and I picked the title Alphabet Soup because the experience for the U.S. in reduction of antimicrobial use began as a way to attempt to differentiate the commodity of chicken in the marketplace. And so there was no unified effort at the start to reduce antimicrobial use. So multiple different companies created different programs to differentiate themselves. No antibiotics ever. Some companies are using the World Health Organization definitions of important antimicrobials. Some companies are using the definition of the FDA. Some are only using non-human important antimicrobials, et cetera, et cetera. So when you go into a company, you have to deal with everyone's internal acronyms. Okay. So a little bit about myself. I'm from Ohio, up there in the Yellow Star near the Cleveland area. Currently live in Dallas, Texas, down there at the Red Star. And I also wanted to talk just a little bit about where the chickens and where the poultry is in the United States. I'm not sure exactly who all is on the call, but get everybody on the same page. Broiler chickens in the United States are circled in the blue circles, mostly in the southern United States, but also a grouping in Delmarva and a significant grouping in California. The significant turkey production is in that yellow gold color. North Carolina being a significant producer, and Missouri, Arkansas, as well as a significant portion in the Central Valley of California. Layer production in the US is in these black circles. Up in the northern part of the United States, the central United States, and some in Pennsylvania, New York, and a significant portion in Texas as well. And that's important because all of these different production areas have their own challenges with climate and disease pressure as well. So this is a screenshot from a fact sheet from the Pew Trust, and it's a long document that is worth reading and worth looking at. It's discussing all the major food companies that are committed to reduce antimicrobial use, and the list on it's a multi-page document, and it explains what their position is, and with links taking you to their website or their press release, and it really explains well the variety of different types of programs for reducing antimicrobial use. And this is a graphic showing the antibiotic commitments for chicken in the restaurant sector in the United States. It's not a comprehensive list, but it shows the amount of powerful brands that have committed to reducing antimicrobial use, and those that have met their commitments, depending on, not all of them are the same strength of commitment, but they've met their commitments. Some companies are working on it, and other companies have no policy in place for their reduction or for their commitment to reducing antimicrobials in chicken. It's important because to remember that who are the customers of the poultry companies that we have in the United States. Companies, major integrators, we think about them, their customers being us, the consumer, but the reality is that the driver of their business is much more with the buying power of these large consumers of chicken, purchasers of chicken to make their food products. Okay. So the first real push in the United States to put into law the reduction of antimicrobial use in food animals was the Veterinary Feed Directive. That directive was published in June of 2015. Again, the goal is to promote the oversight of antibiotic use, and what it requires is that all human important drugs, medications, antimicrobials that go into animal feed require a veterinary feed directive, which is essentially like a prescription from a veterinarian. And to produce that requires a valid veterinary client-patient relationship. Okay. The reason that a veterinary feed directive was chosen instead of writing a prescription is because prescriptions are controlled at the state level, and they wanted this to be a federal program, so they created a federal program to a new classification of a prescription type system. Water administered antibiotics are still monitored, or still need to be managed by a valid veterinary prescription. This document is continuing to evolve. So in January 1 of 2017, growth promotion labels were removed from the human important antibiotics, and human important antimicrobials can only be used with a VFD at this point. And so drugs that don't need a VFD are the ionophores, the chemical coccidiostats, bambamycin, and BMD. There was a guidance for industry 213 that helped these companies that are owners and manufacturers of these antimicrobials to comply with the changing VFD rules. And so there were 292 new animal drug applications that were impacted by the VFD and subsequently this guidance document. Of those 292, 84 of those drugs withdrew their application because they would not be able to meet the requirements of the new law, or the application process and recertification of the drug would be too costly. So of the 208 applications that remained, 93 were for use in water, and they went from over-the-counter status to prescription status. And then 115 products that were intended for use in feed were converted from over-the-counter to veterinary feed directive status. Production indications were withdrawn from all of those applications that included those indications for use. So any product that was labeled for the improvement of gain or improvement of performance only, those were completely removed. But if there was a claim on a drug for improving performance, but also a health claim, just the production indications were removed from that label. And this document continues to be updated. These specific updates are talking about different species, but it's just the point that the VFD is a living document, and it's being continually updated to be relevant and face the issues in the marketplace. Okay. In 2018, this committee released an antimicrobial stewardship plan. It's a 5-year plan that starts in 2019 and will end in 2023. The purpose of the antimicrobial stewardship plan is to align the antimicrobial drug products with principles of antimicrobial stewardship, and foster that antimicrobial stewardship in a veterinary setting, and enhance monitoring of antimicrobial resistance and antimicrobial drug use in animals, specifically animals for feed production. The American Veterinary Medical Association has defined antimicrobial stewardship and the plans, the principles for that stewardship. The first step is fairly obvious. You have to commit to the stewardship, so you can't move forward in a process without making a commitment to that process. And then you advocate for a system of care to prevent common diseases, so improving management and improving standard of care. Select and use antimicrobial drugs judiciously. And so we need to be careful, not just in animal medicine, but in human medicine as well, to be prescribing antimicrobial drugs for the right reasons and at the right dose and for the right length of use. And then we need to continually look at what we're doing and evaluate antimicrobial drug use practices. We need to make sure that we're doing the right thing and we're checking on ourselves as an industry. And then we have to continue to learn, and we need to educate other people about the importance of antimicrobial stewardship. Antimicrobials are wonderful drugs that have saved countless lives, human and animal, and improved performance and health of humans and animals alike. And we need to protect this resource for the future. And one of the ways that we can do that is through a stewardship program. This graph shows the total kilograms of active ingredient of antimicrobial used in food producing animals in the United States year over year. And you can see that there is a significant drop in total volume of antimicrobial use after the VFD rule is put into place, which stands to reason because these drugs are no longer over the counter, but require a prescription or require oversight. And some of these drugs were completely removed from the market. This is a graph looking specifically at antimicrobial or antibiotic use in broiler chickens. You've got on the left side the years that were evaluated, 2015 through 2019, and you have the different classes of antimicrobials in the different colors. So in red, you have the full spectrum antimicrobials, which include the human important antibiotics. And then you have the yellow, which is reduced use, companies that are using, just trying to reduce their use of, the products that have less use in human medicine, but we still use them in animal medicine because they have value. Blue is compounds that are not used in human medicine at all, specifically looking at the ionophores. And then green are companies that are using no antibiotics ever. And you can see that there is a dramatic shift in 2019 to where almost 60% of broilers in the United States are produced without any antimicrobials at all. And if you look at those with ionophores only and reduced use, reduced important antimicrobials, only 3% of poultry, of broilers, use antimicrobials that are important for human medicine. And it's a really impressive change in just 5 years, from 33% of broilers being produced using an antimicrobial that is important for human medicine. So, being said, 60% of broilers in the US are raised without antibiotics, but it's important to remember that not all of those 60% are marketed as ABF. A lot of times it is possible to raise broiler chickens without antimicrobials at all, especially when you're on, for example, a chemical coccidiostat program. Antibiotics may not be needed in that program at all. And the other side of that is there are some major production companies in the United States that have a public stance that they will not eliminate antibiotic use, mostly citing animal welfare concerns. Those public stances are few, but stand in contrast to other companies that are focused on reducing their antimicrobial use. And again, to repeat what I was saying at the beginning, this race to be unique and the attempt to differentiate a commodity has created a program where multiple different companies use multiple different levels of antimicrobials in their system. So what are the challenges when a company is trying to reduce their antimicrobial use? The first and most obvious issue or challenge is intestinal health, because ionophores are antibiotics. So as you're removing antibiotics from your system, it's more challenging to manage coccidiosis, and it requires more attention to detail. As a secondary effect of the difficulty in managing coccidiosis, you have a potential increased risk for necrotic enteritis. Of course, if you have an outbreak of necrotic enteritis, it's much more difficult to treat without antimicrobials. Of course, one of the challenges is decreased performance. These antimicrobials have well-documented impacts on improving performance, specifically feed conversion. Another challenge area is the hatchery, not only from a sanitation standpoint and the need to improve sanitation, but the need to have higher quality chicks coming out of your hatchery. Why is the hatchery such an important place? I think we all understand that the hatchery is obviously a perfect place to incubate chickens. That's what its job is, but it's also a perfect place to incubate bacteria. It's humid, it's warm, there's plenty of substrate for bacteria to grow, and that makes, if you're not able to use antimicrobials in the hatchery anymore at day of hatch, or in the eggs, then it's absolutely important that your hatchery is even cleaner than it was before. It's always important to have a clean hatchery, and I think that one of the benefits of the U.S. Reducing its antimicrobial use is that we've discovered just how dirty the hatcheries were, and have improved sanitation, and that improved sanitation has in turn improved chick quality more even than we've received more benefit than just removing the antibiotics. We've gone back to a time when we understand the value of sanitation. The other thing that's very important is chick quality, and not just from a hatchery standpoint, but from a production standpoint. If you've lost one of your tools to improve performance and to manage performance, it's even more important than ever to start with high quality chicks in your system to get a good end result. Okay. So I think the most important thing about when you're discussing switching from removing antibiotics from your system is there's no secret to improving performance, and there's no secret to managing an ABF system. The secret is best management practice. Do all of the things that we all know need to be done. You just need to focus on them a little bit more because we've lost one of the tools in the toolbox. So that includes good vaccine program, the correct vaccines applied the correct way at the correct dose, quality feed, pellet quality, quality ingredients, and quality feed delivery and on-time feed delivery, appropriate ventilation, cleaning, biosecurity, hatchery management, chick quality, all of the things that we know are very valuable. Once we go through all of that list, then we need to and can start to think about the feed and water additives, these non-antimicrobial feed additives and water additives that can help performance and can help animal health. And so one of the major challenges when going from an antibiotic program to an antibiotic-free program is that intestinal health, and it's very important to manage the microflora. Having appropriate intestinal microflora reduces the likelihood of infection, and not only infection such as necrotic enteritis, but infection in the whole chicken or in the whole animal. Okay. The intestinal microflora impacts metabolism, and it also impacts the immune system development as a whole. So having strong intestinal microflora is key to having a strong production system. Yeah. And so stable and mature microflora is key. So some papers, some quotes from some papers, probiotics have been shown to help mature cecal microbiota And also it's been shown that antibiotics retard that maturation. So using probiotics is one tool in the toolbox to improve that cecal microflora and intestinal microflora. And we know that in the literature that microbiota plays a central role and a very important role in the total immune system of the chicken, but really for all animal species. So when you're looking at the alternative to antibiotics, what products are there, and which products are the right products? So there's the market, as we know, is absolutely full of different products. There's probiotics, prebiotics, there's fermented products, there's plant extracts and enzymes and organic minerals, organic acids, and other products as well. And then of course there's the blends of all of these. So when you start to look at your choices, the possibilities are basically endless on what you can add to your feed or add to your water to help improve performance. So for this part of the discussion, I'm going to go through several of these different classes and provide some of my thoughts about them. So probiotics are microorganisms which, when administered at the correct amount, confer a benefit to the host. And when we think about probiotics, we need to discuss what is an ideal probiotic. And the ideal probiotic, it must be safe, it must be able to survive the GI tract, and of course it must be useful. To remember that the GI tract is designed to limit pathogens, and one of those is bacteria. So when a probiotic enters the stomach, it has to be able to survive the low pH of the stomach or the proventriculus before it even makes it into the intestinal tract to provide that benefit. So when you're selecting a probiotic, you need to think about the rigors of the GI tract and just how aggressive of a system that it is. Okay. And we talk about probiotics a lot in human medicine and intestinal health and in animal medicine because they've been around forever. For millennia, people have been using probiotics. We've been using probiotics since before we knew what we were using. The first known, first recorded use of probiotics was actually from the Bible, and they're talking about drinking milk. And at that time, milk, obviously there was no refrigeration, so these milk products were fermented milk products that had antimicrobials or had microbiota in them, and they acted as a probiotic. The probiotic bacteria was in them very much like a yogurt type product. And actually, Hippocrates named milk as a food and a medicine for curing stomach disorders. Of course, he didn't realize at that time that milk, again, that fermented milk, was full of beneficial bacteria. But he was, and people at that time were intelligent enough to realize that there was value other than just food in these fermented products. When we discuss probiotics for use in poultry, there's two major categories that I like to think of. One is your non-spore forming probiotics. These are often organisms that are colonizing to the chicken, so Bifidobacterium, Lactobacillus, and your Enterococcus species. And the intent of these products is to shift the microbial population in the intestine and by colonizing. And so they're space occupying, they're occupying the space for potential pathogenic bacteria, but they're also producing metabolites that change that the microflora of the intestine. And then your other category is your spore forming probiotics. They're very appealing to use because spores are extremely durable and are much more likely to survive pelleting. than some of your other probiotic choices. Typically are not considered colonizing organisms, so they need to be fed on a regular basis in order to be effective. Many of the bacillus that are used, many of the bacteria used are bacillus species, and those are soil organisms, so they're not particularly well suited for life in the intestinal tract, which is why they need to be fed continuously. And the intent for using these spore-forming bacteria, the bacillus, is to capture the metabolites or take advantage of the metabolites that these bacteria produce: enzymes, acids, other bioactive metabolites. And we know that they produce these metabolites because one of the antimicrobials that we can use, bacitracin, is produced by fermenting a specific strain of Bacillus licheniformis. So the products that these, the metabolites that these bacteria produce, it makes sense that they can confer a benefit to the host. Another class of products is prebiotics, and in short, prebiotics are just food for beneficial bacteria. They're complex carbohydrates. The animal can't digest them, and but the beneficial bacteria can. Two examples of prebiotics are mannose-oligosaccharides and fructooligosaccharides. And then if you blend probiotics and prebiotics, the term for that is synbiotics, and that is valuable because you have a mixture of the probiotics, the beneficial bacteria that you want, and the prebiotics, which are food that helps select for those probiotics in the system, in the intestinal system. And you're providing multiple modes of action at one time to improve animal health. And two of these sources, one of the sources for mannose-oligosaccharides is yeast cell wall. In addition to the mannose-oligosaccharides, there's beta-glucans in yeast cell wall, which have data supporting immunomodulatory impacts. And another source of prebiotics is inulin, which is a source of fructooligosaccharides. Okay. So when looking at another category, yeast and yeast culture, so live yeast is technically a probiotic because it's a live microorganism. And then you have the fractions of that yeast. So yeast cell wall, it contains those prebiotic carbohydrates that just mentioned. In addition, beta-glucan and chitin have published impacts on the immune system. Live yeast obviously has cell wall in it, but additionally it can be metabolically active, especially in longer-lived animals like turkeys and pigs. Yeast culture is another class of product. When producing a yeast culture, what's typically done is a live yeast is added to a specific substrate, some type of grain, usually, and then that product is fermented, and the goal is to provide the animal with the metabolites of that yeast fermentation process. Again, you're going to have some small amounts of yeast cell wall and possibly some live yeast in that yeast culture, depending on how the culture is prepared. And a much larger category of products is the phytogenic feed additives, and I think this is a very interesting class of products because they're of their chemical structure, right? So I think a lot of people dismiss these products because a lot of them are derived from spices, but we need to remember that phytogenic compounds are plant extracts, and there are several well-known plant extracts that I don't think anyone is going to disagree with their efficacy. One example is codeine is an extract from the poppy plant, and aspirin is an extract from the willow tree. And so we know that these products work. And if you look at their structure, they're chemically complicated with a ring structure and OH groups. And if you look at these, some of the typical phytogenic feed additives, like cinnamaldehyde or capsaicin from the chili pepper, you can see that they have similar components to their chemical structure. And I'm not saying that any one of these products works specifically, but we know that from the literature that they have bioactive capabilities, and I think that in general we need to give, as an industry, we need to give them a better chance than we do. And if you look at the literature and you pick one of these phytoactive compounds, for example, cinnamaldehyde, and you look in the literature, there's as insecticide properties, anti-inflammatory properties, antimicrobial properties, and there are papers discussing the mode of action. So not only is there a known effect, but many of these products, the mechanism of action is also known. And that's not saying that cinnamaldehyde is going to solve all of your poultry issues. There is one of the things I think about is, because these are extracted from plants, what is the consistency and quality of the product, and what is the effective dose? How much cinnamaldehyde, for example, do you need to produce an anti-inflammatory and or an antimicrobial impact in a chicken? Another class of products that has a significant body of literature surrounding it are the saponins. They are compounds that are soap-like, have soap-like or foaming properties. There's well-documented information from the literature talking about their impact on as an antimicrobial and as anticoccidial. They've been used by the indigenous populations of where they're from, Mexico or South America, depending on the product, as soaps. So we've used them for a long time. They're used in cosmetics and in food products as well to create foam when needed. So they're safe. They're an interesting product class. I think there's a lot of opportunities to use saponin products for poultry intestinal health, specifically related to coccidiosis. Another product class is organic acids. You have short chain fatty acids like formic, acetic, propionic, butyric, and lactic, and you have medium and long chain fatty acids and citric acid. So we know that some of these short chain fatty acids are directly antimicrobial. Some of them, like specifically butyric and lactic, have a body of research around them for in supporting intestinal health. With relation to butyric acid, I think there's quite a good amount of work discussing cecal health specifically. There's also pathogen reduction work like salmonella reduction related to butyric acid. These can be delivered through the water or through the feed. And I think that organic acids have a role to play in intestinal health, and even more so when antimicrobial compounds, when antibiotics are not able to be used. Bacteriophages are another class of products. Bacteriophages are really interesting little viruses. They are very good at killing their target bacteria, but the problem is that they're very specific to that pathogen. So when you're looking at bacteriophage literature, it's really important to pay attention to not just the amount of the log reduction in, let's say, salmonella, but is that salmonella, was it selected for sensitivity to the phage before the trial was started? The other issue with bacteriophages is they can be difficult to administer. They tend to not be temperature stable or pellet stable. So they have to be, by and large, distributed through the water, but they also need to be kept cold. So you have to think about appropriate cold chain management when delivering these on the farm, which is not, it does not make their use impossible, but it's just another difficulty to overcome using this class of product. Another product to mention, or class of products, is enzymes. I think it's really important to, as part of high quality feed, to use enzymes to reduce extra nutrients. That reduces the nutrients that are available for pathogenic bacteria or to cause GI upset. You can use enzymes to also to reduce the feed viscosity, which is especially important when using when you're not using a corn-based diet. Again, it improves digestibility. Enzymes can help with improving in performance. There are some commercial products that are enzymes that are specifically related to intestinal health and not marketed for not marketed to nutritionists for nutrition to relieve extra nutrients. But one of them specifically is a peptidoglycanase, and it is marketed to help degrade the peptidoglycan from bacteria to help improve performance and improve the immune system in the GI tract. So with all of these feed additives that are in the market, what's the correct feed additive? And I think that the most important thing to think about is that the feed additive that you're selecting is the correct feed additive for the problem that you have. And so you need to very clearly define what is the issue and then look for a solution for that specific problem. I think that it's really important that we use the best evidence that we can to select these additives. There are lots of them out there, and evidence or good quality research trials are absolutely critical to picking the additive that we need to use. And we need to be mindful of the production of these products. Are they consistently produced? Is there a way to monitor that product so that you know what you're getting, what's in that bag or in that tote is the same every time, so that you know how to dose it appropriately. So in summary, the most important thing is good management. No additive, no antimicrobial can completely overcome poor management. It's absolutely key. It's really important. These additives, high quality feed and water additives, can help performance. I think some of these classes stand out above the others. Prebiotics and probiotics have been used for millennia, as have plant extracts. I think there's a strong opportunity for these extracts to be used in poultry medicine and in poultry feed. We know that acids can be directly antimicrobial and can modulate and modify the intestinal microflora. I think additionally that blended products are the way of the future. I think you need multiple modes of action inside these products because none of them alone are clearly as strong as an antimicrobial, as an antibiotic. So blending different modes of action, I think, provides a a broader approach to managing the system. With that, I will take any questions.
Thank you, TJ. We got a question right here. In the field, how do you determine which are the best programs or mixes of alternatives?
So the first thing you have to do is understand what your challenges are, and then look for solutions that match those challenges. And every company is going to say that they can solve all of your problems. So it's critical to have a level of trust with your supplier, to have a company that you believe is being honest with you and truly wants to help you improve your performance.
All right, thank you. Yeah, how do you also consider the interactions that these feed additives may have with each other in the diets? Have you ever looked at any of that?
Yes, some of them certainly do interact, and you want to try and find the positive interactions, obviously to either additive effects or a synergy. And clearly there's the potential for negative interactions. Like if you're using something, I'm going to pick on cinnamaldehyde again, which is known to be an antimicrobial, and you mix that with a probiotic, are those two competing with each other? Is that causing an issue? Maybe. I think you need to think about that. I don't have a specific answer, but you definitely need to be mindful of the modes of action, or at least the purported modes of action for these products.
All right. And then what other enzymes are available in the marketplace that are targeted specifically for immunomodulation versus nutrition?
Just the one that I know of, that peptoglycanase. There may be others, but I'm not aware of them.
All right. Can you differentiate between the goals and mechanisms of liquid organic acids as water acidifiers and protected organic acids in the feed as more of antimicrobial agents?
So if you're trying to use these antimicrobial or these organic acids in the water, clearly they have antimicrobial properties because they're acids, right? The shorter chain, I think, they do better at reducing the acid because they have a lower pKa. And some of the longer chain, like butyric, like the longer chain, short chain fatty acids, I think have more bioactivity in the intestinal tract.
Yeah. All right. This is a question I actually had myself that was asked. Can prolonged or constant use of probiotics cause or contribute to disease flare-ups, almost causing dysbiosis?
It's a good question. I think if you're using probiotics like you're colonizing organisms, those I would think no. Those products are a lot of them are isolated from chickens or other animals from mature microflora. But if you're using a probiotic like a bacillus, where you're really using it for its metabolites, potentially. Anything is possible, right? Biology is a really complicated system, and animal production as well. So anything is possible. I think it's fairly unlikely, though.
Yeah, it's funny. We always ask these questions and want hardcore direct answers, but a lot of times there really isn't a exact answer, right?
If we had the answer, you'd find me on my private island somewhere.
For sure. What do you think would be the nutrient that most affects the potentially pathogenic microflora in ABF production, whether that's excess amino acids, excess energy? What could that be?
I think that's a great question for a nutritionist, Dr. Jared. I'm gonna turf that one to somebody else, but anytime that you have extra nutrients, there's a potential that something's going to eat those nutrients, and pathogenic bacteria like that. If you're adding too many amino acids or too much protein, you have the risk of adding extra ammonia into your house, which has downstream effects for poultry health. As an example, I think obviously the most balanced diet is the best diet, but that's not always possible.
Exactly. Yeah, and I kind of tell people, it's a fine line we play between feeding the good bacteria and the bad bacteria, because a lot of times they like to eat the same things. And the more digestible nutrients that we can feed, the better off we are, because there's less nutrients in the hindgut for all those bad bacteria to take in. I guess if you had one little short thing to say to people looking towards moving ABF production, or people that are there and struggling, what would it be?
Management. Which no one likes a veterinarian to come in and tell you that you need to be better at managing your chickens, but the reality is that's the single best thing you can do for poultry production is have really strong animal husbandry.
Perfect. Yeah, and we know too, you could have the best product in the world, but if your management is not in line, then it just won't work.
Exactly. All of these products, they help. Not all of them, but all of these classes can help, but nothing can overcome bad management.
Exactly. Well, sounds good. Well, we appreciate your time and your expertise, TJ, and thank you for participating with us.
And thanks for having me today.
Oh, you're welcome. With that, I'll transition to our next two speakers, who will be speaking on early neonatal colibacillus in broiler chickens, the role of the breeder farm, hatchery, and early brooding period. Our first speaker will be Thaina. She has earned her DVM and master's degree in animal science from the College of Veterinary Medicine of São Paulo State University in Brazil. Currently, she is a PhD student in the University of Arkansas, focused on poultry intestinal health under Dr. Billy Hargis. Her research focuses on protozoal infections in turkey, mainly Histomonas and coccidiosis. Our second speaker in this presentation will be Danielle Graham. She's a PhD senior student and head laboratory technician at the Poultry Health Laboratory of the University of Arkansas. She has a master's degree on the development of an experimental autogenous Clostridium septicum oil emulsion vaccine to reduce morbidity and mortality associated with dermatitis and the use of antibiotics in commercial turkey production. She's been working on the development of 3 E. coli challenge models and a multi-pathogen environmental bloom model to evaluate formaldehyde fumigation alternatives to control microbial growth during hatchery. Thank you for being here to present for us, and we're excited to hear what you have to say.
Thank you, Jared, for the introduction. I'm just waiting to see if I can share my screen. I still don't see this option here.
See, it should come up shortly.
Okay, now I see it.
Perfect.
Okay. Can you see it okay?
It looks great.
Okay, let me just see if it's okay. So thank you, Jared, for the introduction again. Thank you, Jefo, for the opportunity to be here. And thank you, Dr. Gaydos, for the very informative presentation. I believe this will complement what you presented. And We will focus actually in colibacillosis in this first week of life of a chicken, and we will provide more food for thought than actually concrete answers. I have to say this already. And it's an interesting topic to talk today, this antimicrobial resistance, because today is the last day of the World Antimicrobial Awareness Week, promoted by the World Health Organization. So it's a great opportunity and a great day to talk about this topic. We will present the problem, then discuss the removal of antimicrobial, briefly discuss some possible source of infection and strategies that can be adopted in breeder farms, hatcheries, and broiler farms. We will present some experimental models of infection in the hatchery and conclude the presentation. I invite you to ask questions during the presentation, and we do not own the truth. We will present some possibilities, and it will be wonderful to have your participation. This first week of life of a baby chick is one of the most crucial period in production. It's a time of transition for this animal. The baby chick is adapting to this outside world, and they are very sensitive and immature during this time. First week mortality is a great way to measure chick quality, and colibacillosis is frequently related to this first week mortality. In this study, for example, 70% of this first week mortality was caused by colibacillosis. Colibacillosis is caused by Escherichia coli. It's a very old pathogen in the poultry industry. Everybody have heard about colibacillosis and E. coli at some point. And E. coli is actually a commensal bacteria in the gastrointestinal tract of animals, including humans. But some of these strains of E. coli will have certain virulence factors, virulence genes, and they will have the opportunity to cause disease. And then we call them the avian pathogenic E. coli, APAC. Some clinical manifestations of the colibacillosis include erythrocyclitis, cellulitis, perihepatitis, respiratory diseases. And what is very interesting and challenging about these bacteria is this accumulation of virulence genes and also antibiotic resistant genes. And not only this accumulation, but also the transfer. And this is a problem for human health, because they can actually transfer these genes to strains that will cause disease in us. And colibacillosis, it's frequently seen as a secondary and opportunistic infection in older birds, and it is. But in neonatal chicks, so baby chicks, they are naive, they do not have this a competitive microbiota. So E. coli in this case can be actually the primary pathogen. But in older birds, usually you have this primary cause to have the colibacillosis. You can have an immunosuppressive disease, you can have stress. Okay, now presenting what is happening in Canada from my understanding. For sure, the attendees, the audience knows more than I do about this. But in 2014, category 1 antibiotics, very high importance, were eliminated from the preventative use. Then in 2018, category 2, including gentamicin, inspectomycin. And I believe category 3 will be eliminated from preventative use next year. When we talk about removal of antimicrobials, most of the time we will address it as a challenge, and it is a challenge. But I think it's also time to start seeing this as an opportunity, a chance to improve and a chance to fight the real enemy. And I will elaborate in the next slides this opportunity to talk about removal of antimicrobials. This paper is from actually British Columbia, this group here. And if you see in this PDF, you have all the references that I am using for this presentation. So you can read the paper after the presentation. And if you see in this graph, in this left side, we have the percentage of isolates that are resistant to antimicrobials. And here we have only E. coli and different classes of antimicrobials in broiler chickens and turkeys from 2013 to 2017. If you see this green line here is gentamicin, and you can see this increase from 8 to 21% in broiler chickens and 12 to 27% in turkeys. And this red line here, it's cephalosporin, and you see this decrease in resistance. And it's a reflection from the elimination in 2014 of this category 1 antimicrobials, because actually this elimination in the poultry industry started even before 2014. But you can see that it was effective and the resistance started to decrease. Here, it's basically the same information. This group is from Ontario, so this data is from Ontario. And if you notice here in 2014, you see an increase in resistance in gentamicin and spectomycin, and a decrease in resistance in ceftofor. These 4 graphs here, you can see different classes of antimicrobials and just the percentage of E. coli that are resistant to these antimicrobials, and in different countries of the world, the main broiler producing countries of the world. And the message here is to understand that it's a global problem, and I believe we are relying on a tool, antimicrobials for colibacillosis, that are not actually working anymore. So we were masking a problem with antimicrobials, and now we have this increase in cases. But the tool that we believe it is the solution, it is not the solution. It's not working anymore. So we need to understand what is happening and what are the opportunities to actually fight this problem. Okay, now back to chick quality. Chick quality, we cannot only say that it's a problem in the hatchery or something in the broiler farm or breeder farm. It's an integration of these 3 different sectors, and for sure the connection between these sectors. And what happens in the breeder farm will reflect in the broiler farm, and same for the hatchery. And it's important to work together to understand each other and to see how can we improve as a whole. And as veterinarians, as nutritionists, we tend to focus a lot in the animal only, in the animal biology, in the effect of a pathogen in the animal, but we should start considering the environment as a patient as well, and the whole of the environment in this biology, in this ecosystem that we have. And we can see, for example, the broiler house. I like to see in this way the broiler house as a living organism. We have the litter that can provide a rich microbiota for the animals. We have the ventilation system working as lungs in this living organism. We have the drinking lines that can be the circulatory system. And we need to understand this different living organism and see how we can work together, considering the animal being part of this ecosystem, and how can we improve all of this. And the same for the hatchery, and the same for a breeder house. Now we will briefly talk about some insights from breeder farms, hatcheries, and broiler farms. We could spend a whole course talking about each one of the topics that I will briefly cover. And I apologize if I do not give a lot of details, but that's what we can do with this short time. And again, use this opportunity to reflect and to think for yourself, how can we deal with this problem? In breeder farms, coliform salpingitis is one of the main causes of mortality. And the contamination of the offspring can happen either by fecal contamination of these hatching eggs in the environment or this intrauterine contamination. There is an increase in this contamination, not only the vertical transmission, also the environmental contamination after 40 weeks of age, especially because the eggshell, the quality will start to decrease. You have a thinner eggshell and a porous eggshell. But what it's important to understand here is this contamination can happen in the breeder farm, but it's not only there the problem. You have this first source of infection, and probably you have the spread of the disease actually in the hatchery, as we will talk in a few minutes. In this graph, you can just see the increase in isolation and incidence of E. coli in older breeders. Some possible strategies that we could consider in breeder farms include avoiding FLORA eggs. And when we talk about avoiding FLORA eggs, it's not only increasing the frequency of collection of eggs, for example. We actually have to start properly training these breeders to use the nests, to lay eggs in the nests, and keep these nests an attractive environment for these breeders to lay eggs. We need to consider the whole environment, the whole barn. So we have to keep a proper stocking density, light and ventilation, creating a very uniform environment. Then the breeder, the animal will not have to choose. And it's not will be uncomfortable to go to the nest to actually lay an egg. Cleaning and disinfection of eggs, it's not a new concept, but it's still controversial. And there are some, this recent paper talking about using UV light, prussic acid, and hydrogen peroxide to disinfect these eggs in the breeder farm. Ideally, these eggs will be disinfected within 2 hours that they were laid. In Brazil, for example, I'm from Brazil, it's common to actually use formaldehyde in the breeder farms. So we have different options, but for sure, formaldehyde, it's something that we are trying to move away from this because it's a hazardous substance. For the other factors, egg handling and storage, biosecurity, water and feed quality, they are not specific for colibacillosis, but it's still important to mention them. For example, when we talk about egg handling and storage, we are talking about decreasing the stress in this embryo. If we have a long period in storing these eggs, for sure we decrease embryo quality. And same for all the conditions, the temperature and the humidity. Biosecurity, it's something that sometimes we listen a lot and it becomes even too abstract. But thinking about biosecurity and pest control, for example, it's crucial to be very proactive about pest control because they can be the carriers of this pathogen. They can be the ones bringing this pathogen. For water and feed quality, we need to avoid fecal contamination. Water nowadays, we talk a lot about these biofilms inside drinking lines. And the only way of knowing if in the farm that you are working with, if it's not a problem, it's checking. We need to check, we need to measure. It's the only way of knowing. Boosting immune system and vaccines, I will discuss when I talk about broiler farms. Now moving to hatcheries. So we have this possible source of infection in the breeder farm. Then some embryos will be carrying this pathogen, and some critical points in the hatchery includes hatch, chicken handling, and transport. So you can have a spread of this pathogen during these moments. And it's not only about the animals. You also have a problem in the environment. And again, it's important to start considering the equipment, the machinery, the environment as a patient when talking about infectious disease. And in this paper here, the possibility of formation of biofilms in hatcheries is discussed. It's not our goal here to talk about multi-stage and single-stage incubators, but my point is just single-stage incubators, they are easier to clean, to properly clean. And I will show a paper in a few seconds, just explaining better multi-stage and single-stage incubators. This paper here, it's E. coli isolated from different hatcheries in different parts of this hatchery, including equipment, including infertile eggs. And the goal here is just to see this variation between samples and between hatcheries. You can see here, incubators were one of the most places that E. coli were isolated. Then we go to infertile eggs. You also have the hatchery machines, and in this case here, water. So you see the importance of all these different parts in the hatchery. And what I want to bring with this table here is to ask, what do we know about our hatcheries? And do we only assume that we do not have a problem, that we do not have E. coli, or are we actually measuring it? Do we know it? Because if we do not measure, we do not know. We cannot just assume that it's not a problem. This is the paper that I mentioned about multi-stage and single-stage incubators. I recommend this reading. It's a very recent paper. And I just want to show that in this case, in this study, they showed that in single-stage incubators, the chick quality was improved. And if you have chick quality, you have a stronger chick and a chick that will be able to fight infections, not only colibacillosis, but infections in general. Some possible strategies in hatcheries. Again, just Dr. Gaydos already said this. We have to have a good cleaning and disinfection program and making sure that it's actually good. And again, the only way of knowing it's measuring. If you believe the cleaning disinfection program is efficient, but then you see organic material in trays, boxes, it is not effective. Water, again, you have to check for biofilms. You have to not only trust the source of the water. And equipment. Preventing stress and biosecurity are general things, again, but that will provide an opportunity for this embryo, for this chick, to be actually strong and to fight all the challenges that this animal will face. Now moving to broiler farms. So we have this vertical transmission or environmental transmission in the breeder farm, then the spread in the hatchery. But even if you have an animal that didn't get infected in the breeder farm or in the hatchery, this possibility of infection, it's still real in the broiler farm. You still can have a source of infection in the broiler farm. This can be pests, feed, water, and E. coli is a bacteria that it's easily present in different environments. Dust, you can find E. coli. And if you have an animal that is stressed, that didn't have a good start, this animal will be susceptible to different diseases, including colibacillosis. Remember that E. coli, if you give some virulence factors and the opportunity, they will cause disease. Some strategies, I will never get tired of talking about the importance of a proper brooding period. This is crucial, and it will not start only when the animal is in the house. It starts before preparing this environment to receive the animals. So having a sanitation, a cleaning of this environment, and having feed available and quality feed. proper light to have this active baby chick in these first days in the house. Air quality, we have to start ventilating and heating this house before placing the birds, making sure that we have water quality and water available, the temperature of the water, respecting all the time priority welfare, and again, just sanitation, security, space, and of course, staff. Most of the time, we are the staff, and we need to be aware of our importance in this whole system. Here, just talking about boosting immune system and vaccines, Dr. Gaydos presented the different alternative compounds to replace antimicrobials, and I will just here in this picture, you see this feeder that is dirty. We do not want to start the life of a baby chick in a feeder that has a lot of organic material and can for sure be a source of infection for this immature animal. Okay, so he presented the different alternative compounds. I will briefly talk about probiotics, just complementing some information. And my goal here is just to say that I truly believe in probiotics, but they are not the magical pill. They are not the solution. And any of the alternative compounds, as Dr. Gaydos presented, they are not the solution for all of our problems. And talking about colibacillosis specifically, it's even difficult to compare the different options that we have, because there are different products, different bacteria present in this probiotic. The model of infection, the way that we will induce the colibacillosis is different. It will vary according papers. And sometimes the effect of this probiotic will be wonderful for one particular strain of E. coli, but not the same effect in a different strain. And it's crucial to remember the genetic variation of E. coli. So they have different genes, they have different antigens, and it's never the same. And the result that we see one time maybe is not the same that we will see in a different condition. So I think it's important to be aware of probiotics, and before using, making sure, try to look for scientific evidence that it will work, and it can have this direct effect against E. coli, against some strains of E. coli, but it's interesting to consider the indirect effect, helping the animal, promoting the immune system of the animal. About vaccines, it's still the same problem that you probably heard years ago. With all this genetic variation of E. coli, it's difficult to have a vaccine that will offer cross protection between different serotypes. But I would say that is something to keep pay attention, and science and research keeps evolving, and hopefully one day we'll reach the point that we have a vaccine that is actually effective. So keep your eyes open and keep informing yourself about the options that are coming from research. Now I will pass the word for my colleague Danielle.
Thank you, Thaina, and thank you, Jefo, for this opportunity. I'm just going to expand a little bit on the experimental models that we've developed to evaluate formaldehyde fumigation alternatives, and then also some alternative compounds that may be that could be used. So we know that in nature, chicks receive microflora from the hen, whether that be during oviposition or from the environment via coprophagy. However, the reality commercially is that the eggs are promptly removed from the hen, and there may only be beneficial microbe transmission minimally at this stage. And so if there's any bacteria present on the surface of the eggshell post-lay, there's potential to penetrate and even replicate within the developing embryo. And this can be lethal depending on the organism that penetrates. However, if those that are infected do actually hatch, you do see textbook horizontal transmission between the infected chicks and the naive population as the microbial bloom occurs during the hatching phase. So these initial microbes are the pioneer colonizers that these naive chicks are exposed to, and it can really have meaningful effects on these neonates. And I know we all understand the importance of pioneer colonization by beneficial microbes, but it needs to happen as early as possible because they are involved with nutrient processing and absorption, tissue maturation and development, as well as involved in competitive exclusion of potentially pathogenic organisms. And so Thaina referred to it being an opportunity. It's a challenge as well, but also an opportunity. And so this is what our group has focused on research-wise for some time. And it's focused around the ongoing problems in the industry. And so we want to evaluate commercially applicable techniques to expose these neonatal chicks to beneficial microbes, like I said, as early as possible. And we've also worked to develop challenge models to evaluate these products, as well as to control the microbial bloom during hatch to hopefully find alternatives to formaldehyde fumigation. With the overall goal, I think everyone agrees on that as well, but is to improve performance and well-being for these animals. That's our primary goal. So moving forward to controlling the microbial bloom in the hatch cabinet, we know formaldehyde is completely effective, but it's not selective. So it also eliminates those beneficial microbes. Today, the focus is on colibacillosis, but I just want to point out some of the other presumptive pathogens within the hatching environment. And we've also worked on a model including some of these other pathogens as well. Like Thaina said, and to know what's there, you need to measure. And so we have a few select methods that we like to use for our research to determine the microbial population and the effects that some of these products have on the bloom within the hatching environment. And those include the open auger plate method, which is sampling the air circulating in the hatching environment, a composite fluff sampling post-hatch, which is a really nice way to look at what's there, and of course gut sampling post-hatch as well. So I'm going to give a brief overview of what we mean by these horizontal transmission models, specifically for E. coli. We use a cedar challenge method, which means that we only inoculate or challenge a small percentage of the population, so usually less than 10%. And this reflects the real world scenario under laboratory conditions. As these infected chicks hatch, they spread the pathogen to contact chicks, so those that were not directly inoculated. And so these are novo-based models where we have one for APEC and one for also wild type E. coli. And what I mean for that are field isolated E. coli, things like that do not have APEC characteristics. And just a brief overview of a couple of the trials that we have conducted for the wild type cedar model. This is looking at the gram-negative bacteria recovered from the hatching environment, and we're showing two trials here. We have colony forming units on the y-axis and then the treatment group on the x-axis. Thaina, by the way, you're doing a great job running the pointer. We have a negative control, NC positive control, and then E. coli plus form just means it's essentially the positive control, but those hatchers were fumigated with formaldehyde. And you can obviously see here that there's a large increase in gram-negative bacteria recovered as a result of this model, and that, as expected, formaldehyde effectively controlled the artificial bloom, just validating that our model, we created the bloom, and that formaldehyde, the percentage that we were including, controlled that bacteria. So of course, gut sampling at day of hatch. This is looking at the gram-negative bacteria in the gut for the contacts, as well as the cedars for the positive control, and then also the hatchers that received formaldehyde fumigation. And we already saw that the formaldehyde controlled the bloom, and as a result, there was a reduction in gram-negative bacteria recovered from the gut of these contacts, but we also saw that the formaldehyde did not penetrate the eggshell of the seeders, just showing that it controls the bloom, but it's not controlling any of the pathogen replication within the developing embryo. We also noted with these models, we're just showing a couple of trials here, but we did see inconsistent effects on 7-day performance. And so we decided to move forward with an APEC strain. And interestingly, we had to take a different route with this. To be expected, if you administer APEC in novo, even late during embryogenesis, it's extremely lethal to those developing embryos. And so this required a co-administration of tetracycline hydrochloride as well as the APEC and at low colony forming units per embryo. And so this allowed the E. coli to delay the replication of the E. coli and allowed those seeder chicks to hatch and therefore transmit that APEC to the contact chicks within the hatching cabinet. And since we've already shown some of the data from the hatching environment, we're just going to focus on 7-day performance here for 3 trials. And what I just want to note is that we did have a significant reduction in 7-day body weight gain for the contacts compared to that negative control, and a significant increase in mortality in that contact group compared to the negative control, which is to be expected with the APEC strain. We also noticed that we actually induced respiratory colibacillosis in these neonatal chicks. And this makes sense because it's the pioneer colonizer. There's nothing to exclude that APEC strain from proliferating. And so this was an interesting note from our group. Once we validated the model, we started evaluating some probiotics in novo, and here I'm showing data from lactic acid bacteria culture in novo at day 18 of embryogenesis, and then those seeders within the hatch cabinet, I believe 10% seeded environment for this model or this experiment as well at day 19. And so as those seeders hatched, the chicks that received the lactic acid bacteria on day 18 hatched as well. And so we saw a significant reduction in gram-negative bacteria recovered from the gut at day of hatch and day 7, and as to be expected, an increase in presumptive lactic acid bacteria at day of hatch for those chicks that received the lactic acid bacteria in novo. And just to summarize performance for these 2 trials, no impact on hatchability, of course, but we did see marked increases in early performance, as well as a significant reduction in 7-day mortality for those chicks that received the labs a novo, which was interesting, and showing that these probiotics and I'm sure other alternative compounds can shift the microbiota in a positive way. And so to evaluate other methods or products, you need to have models, right? At least in our research. So we can confirm that these are tools that can simulate that microbial bloom that occurs during hatch. We showed data for only E. coli here, but we have another model that includes other pathogens that harbor within the hatching environment, with the goal to investigate alternatives to formaldehyde fumigation and obviously promote early establishment of beneficial pioneer colonizers under challenge conditions, but also under commercial conditions. And I think we can all agree the overall goal is to reduce neonatal colibacillosis, and it's going to have a lasting impact on the animal throughout their entire life.
Okay, so here just some final thoughts. As Dr. Gaydos said, antimicrobials, antibiotics, they are a wonderful tool, and they just need to be use with responsibility, and we need a prudent use of these drugs. And to know when to use, we need a proper diagnosis, and we have wonderful diagnostic tools, culture, molecular biology, serology, and just use the correct tools to diagnose this problem, not only in the birds, but also in the environment. And when okay, I have this bacterial infection and I need an antibiotic. Choose one that it's actually working for this pathogen, and not just, oh, this one, I believe it will be effective. No, before using, make sure that it's actually the correct tool for your problem. Keep records every time, what was used, when was used, the dose that was used. And this is just a reminder about this World Antimicrobial Awareness Week. And there are a bunch of information from the Food and Agriculture Organization, World Organization for Animal Health, and World Health Organization. To conclude this presentation, we need to be proactive and radical about this challenge, and see this also as an opportunity. And it's funny because it's the same conclusion that Dr. Gaydos presented. Management is key, biosecurity is key, and we have all these alternative compounds and some vaccines that they can be helpful in some situations, that they can be beneficial, but without management, without biosecurity, there's no miracle. Keep educating yourself, educate others around you, and we need to communicate between all the different sectors and be transparent always to achieve this goal as a group. And thank you. That's all that we had for today.
Thank you both for an excellent presentation. And as we know, in Canada, E. coli is one of our biggest issues that we face in poultry production. So it's always good to learn more about how we can help reduce and mitigate some of those issues. So I have a couple questions here. Besides formaldehyde misting, are there other forms or products that you've seen used in hatcheries, maybe peroxides or things of that nature that have been shown to be effective?
Danielle, I think you have the answer. You're muted, Danielle.
Thank you. Yes, most of what I know is revolves around a spray application of a probiotic. So then you're also controlling that bloom, but also presenting the pioneer colonizers, the beneficial ones, earlier on. But of course, some of those other methods are also used.
All right. Another question, should FLORA eggs be used, especially in flocks older than 45 weeks?
Can you repeat the question, please?
Should we use FLORA eggs for hatching?
Oh, FLORA eggs, okay. Well, we need to avoid FLORA eggs during all the production, and it's one of the most effective way of transmitting a disease, not only colibacillosis. So I would say avoid FLORA eggs all the time. And this goes back to what I said, like training the breeders, and this will start early in the production, and this is key to avoid FLORA eggs and working the environment of the house.
All right. Yeah, so we have this issue in Canada where we do wash FLORA eggs, but it becomes an issue in how you wash them correctly. It's your water temperature has to be correct, and the disinfectants that you use need to be appropriate for live organisms.
Yeah, it can be controversial. Again, it's not a new concept, but it is still controversial and sometimes difficult to understand, because we can damage the cuticle of the egg, but at the same time, we have all these people saying that we should disinfect the egg, so it can be controversial. And I think we have papers for that. We have science for that. And old concepts can always change with this new information. So I believe now we have more effective ways of disinfecting these eggs, not damaging this cuticle and not creating a threat for the embryo.
Very good. Have you seen any relationship between the incidence of E. coli and Enterococcus faecorum?
I will not say that I saw it with my own eyes, but I read the paper. And there's I don't know if I included in the reference section, but if it, do you want to know or somebody's asking?
It's a question. So
Okay, yeah, I don't know the name of the paper, but it's a recent paper saying that yes, there is a correlation with Enterococcus and E. coli.
Very interesting. Yeah, it's, I guess maybe the E. coli opens up everything to the Enterococcus, and
Yeah, it's difficult to say who is opening the gate because E. coli, again, we'll see an opportunity. Okay, I will enter, I will go, and I believe for Enterococcus is something similar. So it's difficult to know who is causing the problem there.
all right. I know that y'all talked about in novo vaccination of probiotics. How do you think that compares to strong probiotic dose at day of hatch in the house, in the feed?
Well, you're getting the beneficial guys there first, earlier. And so if there is any horizontal transmission within the hatching cabinet, having that beneficial bacteria there already is going to assist and promote better quality in that first 7 days for sure. Right?
Yeah, if you remember the slide, the presentation, critical points for this horizontal transmission will be during hatching, transportation, chick handling. So if you inject the probiotic before all these steps, you are controlling these critical points. If we delay this delivery of probiotics to the house, in the feed, we have all these steps and the chance of infection, this spread of the disease will increase.
Very good. I believe that's all the questions we have for now. I really like to thank both of you for such great presentation and great information on E. coli, and thank you to our attendees. We appreciate your time, and if you have any further questions about any of these topics, actually there's a question that just came up.
Okay.
Do you have any specific litter treatment to reduce E. coli incidence?
Litter treatment.
Uh-huh.
Well, there are different ways to manage litter, and I believe all of them can have some effect. It's not difficult to decrease E. coli. E. coli is not extremely resistant to the temperature and, for example, a pH treatment. So I think from composting the litter in-house windrowing to applying acidifier in the litter, they are all good options. And about litter treatment, we need to consider all these possibilities and choose one and do this one way, the best way possible. That's key. I will not say that in-house composting is better than applying acidifiers. And I think it's key to just choose one way and do it in the best way that you can.
Sounds good. Well, thank y'all. And if any of the attendees have further questions, feel free to reach out to us.
Please.
We'll be sure to get back to you with answers, and I appreciate everything. Thank you.
Thank you, Jared. Thank you for the attendees. Thank you, Jeff, again for the opportunity.
Yes. Thank you so much.